Alright, so is this gradient intercept form?
Yeah, but like,
No, though.
you can't have two y's.
Right, so gradient intercept form, right, what is the form of gradient intercept form? It is y equals ax plus b, or y equals mx plus c, you'll see it, or mx plus b, or a combination, right? Either or, m is the gradient, c is the y-axis intercept. If it's a and b, no difference, alright? So we want everything in this form, so none of these are. So this first one, as David quite rightly said, we've got two y's, we only want one, so we have to divide everything by 2, and we get 1y equals
Negative 2x plus 4.
negative 2x plus.
Or 4 minus 2x.
Yeah, alright, I'll go with that. That more aesthetically pleasing, 4 minus 2. Looks tidier, doesn't it? Not having a negative on the front. You know why we try and avoid having negatives on the front? I have told you before.
Just because we do.
There's got to be a reason why, right?
I don't remember.
Pardon? It's not actually about making it cluttered because it's still there. I mean, we've got less signs, haven't we, in the second one, but it's actually so that we don't lose the negative sign. Quite often people miss it, or it gets mixed up with equals, or so it's just nice not starting with a negative sign if it's all possible. But I think, Dave, you're right as well. There are less symbols being used. It's more efficient. All right. Everyone good with that one? You'll be able to do that for yourself? About the next one then?
It's just extended form. You have to divide by 10. Oh, wait, no, divide by negative 10.
Okay.
I think.
I mean, that wouldn't be my first step, but it's actually perfectly reasonable. I'm not going to do that just because I think everyone else would find it a little bit more complicated. Anyone else?
Plus 10y.
You need to rearrange
Plus
it.
10y. Why would you plus 10y, Matthew?
By itself.
Well, it doesn't. It doesn't leave y by itself yet. But what it does do is mean we don't have a negative y. What do we do now?
Subtract 20.
Subtract 20. What does that give me?
5x minus 20 equals 10y. And then you just divide everything by 10.
And now we divide.
So half x minus 2 equals y. And you can just like swap this side.
Doesn't have to be y equals, it can be equals y. But yeah, you'll see what happened there. David obviously understands this. 5 divided by 10 is a half. Yeah. It could be 5 over 10. I could have just written 5 over 10. That's rise over run, right? But that simplifies to a half, 1 over 2. And negative 20 divided by 10 is negative 2. That's what happened. Yeah.
Why don't how come when you add 10y it doesn't cancel out?
So again, this first line I added 10y, yeah?
Yeah. Why?
And you're saying it didn't cancel out.
It did.
It did. This minus 10y is gone though. It's not there anymore. It's now over here. Because I had to add 10y.
Why doesn't it go to just y?
No, I get it.
Wait, why wouldn't it be like 30y? When you like.
Because this is 20, it's not a y. It's a 20. Remember, this 10 is not a 10. I can't add it to a number. What is that 10?
The amount of Y's you
The amount of Y's I have. I can't add 20 and the 10 together. Because 20 has got nothing to do with Y's, it's a 20. Alright, what about this next one then? There's a nice easy first step for this one.
Add 9. Wait, no, subtract 9.
I wouldn't.
Add 0.
Yeah, you could do that, wouldn't make any. You can subtract 9. You could do that. I'm just talking this with my M2s. I definitely could do it.
It just
I
puts
just
it
don't
in
want-
standard form.
What do I want? I want the Y on its own. And I want it positive.
So just add 1.
Add 3y.
Add 3Y, that's what I would do. If we added 3Y's, what do I then end up?
0.
0 plus 3Y is
3Y.
3Y equals, well that cancels. So it becomes 2x plus 9. So what's left behind?
Now we just subtract.
Subtract,
Oh, divide.
divide by 3. So if we divide it by 3, we get 1y. And I need to divide the other side by 3. So now this is interesting. How do I put it in gradient and so forth? So 2x divided by 3. 2 divided by 3. How do we write that?
Just 2 over 3.
Yeah. We just write, right? And then we look at it. Is 9 divided by 3 possible?
Yeah.
Yeah.
Nope. Yeah.
Plus,
Yeah.
For
now, common mistake would be, well, I'm going to go to this one. Some people would write this as 0.5x minus 2
Wrong.
equals
Die.
y. That's absolutely fine. I have no problem with that whatsoever.
My bad.
You definitely would not pass to the other world.
I might know.
No problem with it. 0.5. They are interchangeable. I don't like 0.5 because why do I like the 1 over 2 instead of 0.5? Rise over run form, right? So that's easy to see that the rise is 1, the run is 2. If it's 0.5, it means the same thing, but it's not as easy to visualize. 2 over 3, rise over run. Some people would write it as y equals
0.6 recurring.
0.6 recurring
X.
x plus 3.
That's so cringe.
That's fine. It's correct. It's not very nice. It's not very tidy. It's not very neat, but it's correct. Some people would write 0.67x plus 3.
Wrong.
That's wrong. Why is that wrong?
Because you just put 6667 on the calculator. But
And what have I done? I have
Made it.
rounded it. And what do we use equations of straight lines for now, guys?
Predictions.
Predictions. So if my gradient is only a slight little bit off, will it matter?
Yeah,
Yeah.
a lot.
The further I go up the line, the
Farther
more the
off
gradient
goes.
being off will be. Because basically, if my gradient is off, it's not just every number is just a little. It goes up slightly steeper, doesn't it? So the further I go on, the bigger that difference is going to be. All right. So this one we don't. Right. I do not want to see you use decimals and round them. Please do use rise over. Leave it as a fraction. It means everything. It helps you. So leave as a fraction. Alright? This one's fine. I'm okay. That's good. I'll give that a smile, but not a proper smile. That's a sort of half smile. But it's fine. These forms are big happy smile. Alright? And a party hat. Right. Happy with that?
Yeah.
You'll remember how to change the form, all makes sense? Good. Alright, let's have a look at the next thing, which is find the X and Y intercepts. So, what do we know about the x-intercept, Sammy? That's your name, right?
It has a.
What do you mean about the first question?
It's when y equals 0.
You
You
just
bailed him. He wasn't listening.
Oh, my bad.
You bailed him out. You still didn't hear that though. So what does he say?
It's when y equals 0.
So the x-intercept is found when y equals 0, and the y-intercept is when x equals 0. That's all we need to know for this. So how do we use these? Well, the first one we write, if we want the x-intercept, we do 3 times 0 plus 4x has to equal 20. Alright?
Divided by 4.
So 3 times 0 is
0.
0, so we can forget that and just say 4x must equal 20, which means x must equal 5. So I know the x-intercept for this one. So the x-intercept is 5, 0. Right?
The y-intercept is like.
The y-intercept, same idea, but we have 3y plus 4 times 0 equals 20.
It's
4 times 0 is 0. So we know that 3 y's must equal 20.
6.6.
Which means y
6.6.
is 20 divided by 3.
Which is equal to 6.6.
No, I don't. I keep ignoring you because I don't want you to tell me that.
20
Could we write it in a different way?
Equivalent fraction.
6 and
1. No.
almost 6 and 2/3. Do you want to know how to do that?
No, I'm dead.
How many 3's can I take out of 20?
3.
6. That makes 18. How many left? 2.
Oh.
So the y-axis intercept for this one is
6.
0, 6 and 2/3. Again, we're trying to avoid rounding decimal. Be a lot easier to plot 2/3 than it is 0.666. You know, on a graph if I wanted to do it.
I suppose so.
So that's A done. You can do B and C yourself. I am recording it, just so you know. What's your first step?
Well, I did 5 in brackets 0.
So you're going to do the y-axis intercept first, right?
Oh, it's supposed to be y, right?
No,
it doesn't matter.
Yeah.
Y-intercept would be when x is 0, yeah? We're trying to
Okay,
find
yeah.
So if that's what you're doing, that's
Yeah.
fine. So yeah, right, let's do 5 times 0 minus 10 y's minus 30 equals 0. Now that's gone. So we've got minus 10y minus 30 equals 0.
Why don't you
Okay,
just
that's
say
what I
That's
x?
what you got.
did
So
that,
that's
yeah.
fine. That's absolutely fine. David suggested something which would help us, which is, well, let's now just do what we were doing before, just because that's a y, not an x. We still solve for it. So my first step is to add 30. So I get negative 10 y's equals 30. And then we divide by negative 10, and we get y is 30 divided by negative 10, and therefore y is
-3.
negative.
I got the same thing without doing that. I did plus 30 at the very beginning.
So you did exactly the same thing, just in a different order.
Yeah, but I didn't.
Yeah? It's absolutely fine, you can do it in a different order. I just went with this because Nico had already started it. And then of course the x-axis intercept will be 5x minus 10 times 0. Because y is 0.
Equals
Minus 30 equals 0. So then we've got
5x equals 30.
5x. Now here's a question. Is it minus minus?
No, it's plus.
Is it minus minus plus?
Yeah.
So do we change it to plus 30?
Wasn't it just -10y?
Oh, wait.
So the negative's
No, because
completely
doesn't-
irrelevant.
Is it -10y? Because if it's -10y, we just cancel it out.
Next, minus 10y's.
So wouldn't just cancel it out?
Now, what I'm leading you to here to say, what some people would do is this. They would go 10 times 0, what did I do? Cross it out, so I'm just going to cross it out. That would lead people to go, oh, it's 5x minus 30 equals 0. But that is 5x plus 30, isn't it? And the problem with that is,
5x.
if I don't do it in that order, if I do it in the order that Matthew suggested, which is we add 30 first, before I do anything else, actually this becomes not this at all.
What?
It doesn't become this. If I'd have added 30 first, right, add 30, it would become 10 times 0 equals 30, positive 30. Alright? So even if I do that bit first, or the other one first, it has to come up with the same answer. Right? So this would then cross, but then we go, oh, that minus doesn't include, that doesn't do anything. So actually that minus goes with it. So it just becomes 5x equals 30. Which makes x equals 6.
So you don't always have to follow the same order.
I'm recording just in case, just so in case you're saying something.
I didn't even get that.
I believe you'd do something like that, Session. How dare you?
What did I do?
Exactly.
I have put the first level on for both of them, look, so x-axis intercept is when y equals 0, this should be well known to you guys now after our assessment, our criterion B earlier on. We just need to go through this process. So for the x-axis intercept, multiply by 0, we get 0 equals 2x, this is minus 0 something, so plus 12. What do we do at this stage, Connor?
Oh, I put mine.
We did y.
Oh, you were chatting.
Subtract 12.
Subtract 12,
Yeah, thanks.
and we get minus 12 equals 2x, which means 1x will equal
Negative
Negative
6.
6. We go on to the y-intercept, we've got 0
It's
equals
y equals 3, right?
negative 4y plus 12.
Subtract 12 again.
Subtract 12 again, we get negative 12 is equal to negative 4y.
Divide by 4.
Divide by
Negative 4.
negative 4.
Did I write that out?
You get y equals
3.
3.
Sheesh.
Right.
Does it matter the way I did that? Or
Did you
does
get
it
the
matter?
right answer?
Yeah. I did next.
So that's just our criterion C.
I'm recording, just in case. No, not yet. You want you to pay attention, listen, and interact. This is a set of axes. This is the y-axis. Yeah?
Yeah.
That's the x-axis. All right. Could there be a straight line drawn with that axis? Yeah. Okay. If I tell you there is a point that has an x-coordinate of 3, I'd go along here. I'd find 3. What would the next thing I'd need to do? Find 1. So I would basically, where is the y value going to be? It's going to be it's not going to be on the y-axis at all,
Oh, yeah.
actually. It's going to be anywhere along that line, isn't it?
Yeah.
Yeah? So I could pick a point here, down here, up here, anywhere. How many spaces are there for a dot along that line?
Infinite.
Infinite. So where is it? Where's the point going to go? Why don't we know?
We haven't been given enough
Yeah.
information.
Okay. What is the information you need?
The Y.
There you go.
That's what you said.
Y equals 3x plus 2.
Choose the Y intercept.
I didn't ask that.
What's
It's
the
true.
Other part of the coordinate.
I want to know, where does my point go?
Oh, 9.
Where
It
two,
goes
where 2 and
with
3
Y
meet.
equals 9.
The X and Y intercept.
Where 2 and 3
Those
meet.
lines.
Where is the point going to go?
9 on the Y axis.
3, 2. 3, 2.
11.
11. Go up,
Because there's 3 x's, so
Find
that's 3
11.
times 3, 9.
and I put
Plus
points. That point will make up the line. That's one of the points, yeah? How does David know that? David's not
Because
gonna
you
tell us.
just said. You said 3x is 3 times 3.
So you take x, you multiply it by 3,
And then you add.
you add 2. That tells me the other number. This equation is the law, right? It's the rule that gives you the y value that matches to the x value. So we could draw a table of values, couldn't we? Done that before? Do you remember doing that on the board? You know, table that matches with the graph, that matches with the statement.
But the first thing
Remember
we
doing
did,
that?
that was the, like the first thing.
One of the first things with the other unit, yeah. So we could draw a table. Where is another point that makes up this line?
X equals 4, Y equals
Okay, x
14.
equals 4, so we know that this one y equals 11. This one would be
14.
14.
40.
So we go across to 4, and then we'll go up, and go up. That will be at 14. When x equals -1, what will the y coordinate be?
Oh, it's not -3.
So 3 times -1 is -3. Plus 2, -1. So this would be a point, -1, -1, down here.
That's still in line.
And we should, I haven't drawn this very well, but we can draw a line. Now what does the line represent?
An infinite number of
All the possible
points.
values. Remember talking about this? What is between 3 and 4?
3.1, 3.1.
3.5, and that would go with whatever it's going to be. And then there's another point in between there, and another point in between. And if I consider all of them and zoom in, and put all the dots, and then zoom back out again, what will it look like? A line. Right. This is the last thing we're going to do. The bell is almost going to go, but I am going to finish this before we pack up and go. So here is the, I want to make it a bit bigger. Right? Here is the line that's made up by all those points. What do you know if I draw another line like that?
What's it
They will never intersect.
They did intercept.
They did intersect.
Well, again.
They intersected here.
But then they'll never intersect again.
They won't ever intersect again. Good. All right. They intersect at a point x and y. What does that mean?
Sheesh.
The X and Y will
So if I said to you, I've got y equals 3x plus 2 and y equals 12 minus 5x. Alright? They should cross, right?
Yeah. At
This
least
one starts at 2 and goes up, this one starts at 12 and comes down. They will cross
once.
just once. When I say they cross, what I actually mean is, that's another word for cross.
They'll equal each other.
They share a point. Good. That means that if I put the x into here and work out the y, I put the same x into here and work out the y, I will get the same answer. Alright, the same x and y matches together. What are we going to be doing? We're going to be solving systems of equations to figure out where two lines cross. And we have several different ways of doing it. So that's what we're going to be working on next time. And we need to be able to do all those other things that you just understand. Alright, make sense?
Yeah.
Good.